Okie doke, so here I am. This is me with you guys, and here my wife wanted to see me here. I said I'm in London. She was a little bit scared, but I said it's gonna be with these nice Databricks guys. She was a little bit calmed down, but it was just a little bit. So I need to prove I was here. Okay, so. Bucketing in Spark SQL. I'm Jacek Laskowski. I'm an independent consultant focusing exclusively on Spark with some other tools. So I explored Spark SQL, and at some point I stumbled upon this feature called bucketing. It's a brand new feed optimization technique available in Spark SQL 2.1, if I'm not mistaken. Yeah, 2.1. And this is a very short talk just to introduce you to something you may like use in your production just to optimize your queries. It does not cost much, but you need to do or pre-shuffle your data just to make your joins better. Okay, so this is Apache Spark 2.3.1. We've got 2.3.2. And by the way, have you heard about this merge yesterday? Cloudera and Hortonworks merged together. Is this the reason why they are not here? I'm not sure. Anyway, okay, I'm digressing. So I'm Jacek Laskowski. I'm independent consultant exclusively with Spark, a little bit with Kafka Streams now, and some other tools, only because they are used in your architectures with Spark. So yeah, you can reach me at this email address using this old-fashioned ways of reaching out to people, or you can just follow me on Twitter or use some other venues like this nice Spark AI Summit application. Okay, so I'm best known by my Git books. Yeah, we all take notes, right? So I just decided to publish them just to challenge myself and my knowledge, and that's why I'm here too, just to show you how much I know about bucketing, how I use it, and perhaps meet other people who use it and learn something from you too. So, and Stack Overflow, I skip it. So agenda is pretty short because we've got only 25 minutes plus 5 minutes for Q&A. So this is the agenda, motivation, why we are here. It's not only about Spark, but it's about optimizing our Spark jobs. And what's bucketing? So it's an intro. Then I'm gonna introduce you to describe extended or describe formatted. They are same, and just a little bit of summary. Okay, so motivation, why we are here, why we are interested in this bucketing support in Spark SQL. Well, we are concerned with performance of our joins, okay? This is about join performance. So we've got these two tables, okay? I call them, arbitrarily, so huge and large. It doesn't really matter whether they've got billions of records or thousands of records or just two, okay? We are thinking about joins, and these joins concern us because they are slow, okay? So what can we do about this slowness of our joins? Okay, so we've got two tables, and we do this one simple join, okay? It's not very sophisticated. It's just very simple inner join by this one column, okay? I didn't mean to, to overwhelm you with a very complex join. I'm going to show you that this bucketing feature works with work well with simple joins as well as more complex joins. Okay, so I just explicitly disabled broadcast hash join because my data is less than 10 megs. So I didn't mean to, to show you that, there's this broadcast hash join, which is nice. I just disable it, okay? So I just loaded these two tables, huge and large, and I did this join by ID, okay? I triggered an action by using for each. It's just to, see the time of this join explicitly rather than, dealing with the execution time with extra calculation. So this for each and dropping all the results because I'm not interested in them. Okay, so this is what you can see in WebUI after doing this very simple join. you will have sort merge join. Well, I'd say the worst possible join because it's the heaviest, okay? There are others, so you can optimize like broadcast hash join and sort merge join, but this is there is another one. So we've got this sort merge join, and the sort merge join is nice, okay, because this is because of the size of the data, but we are concerned with one thing or two things in this diagram, in this execution plan. What are they? Well, these are the exchanges that we have here, okay? So between filter operator and another operator sort, we have these two exchanges. And we are always concerned with exchanges because they are shuffle our data. We don't want to do this, well, unless there is no choice. But there is a choice to make this better. We know that we join by ID. So we use this information, again, knowing your data and knowing how it's partitioned and bucketed, which are pretty much almost about same. It's about laying out this data in a proper fashion for our queries. We will use this information just to get rid of these two exchanges. Okay? So how? Okay. So this is the question, this is the motivation, and this is the reason why you are here. Can we do better? Can we avoid these two exchanges? Yes, we can. So, bucketing. This is the intro to bucketing. Very short intro, just to give you a glimpse of this nice feature. Not widely used, but I use it twice in my projects, and it gave nice results. So you may try it too. So it's just optimization technique to bucketize your tables. Okay? It works well with data source natively supported by Spark tables, as well as with Hive tables. As a matter of fact, it was contributed to Spark based on how this bucketing support works in Hive, okay? And we know that we are migrating from Hive to Spark because Spark is great because of the feature it has. It's just Hive++, using this comparison between C and C++, and assuming the C++ is better. So, optimization technique. And it uses buckets and bucketing columns, okay? So, it's almost like partition by or partitioning, but with partitioning, you don't specify number of partitions, correct? It's being calculated for you. Now we are saying we want to use n buckets by these bucketing columns. Okay? These bucketing columns are used to calculate hashes of our data and put them into our buckets. So it's just a very simple calculation like, give me a row, calculate a hash of this row, divided by modulo number of buckets, and put it into the bucket by this ID. Okay? That's very simple. Okay, nothing, exceptional. We saw it we use it perhaps in other systems too. So it specifies physical data placement. So we pre-shuffle our data because we want to avoid this shuffling, this data shuffle at runtime. So now you might be asking yourself, why am I doing something I can do at runtime? Why should I be bother myself with this extra step? Do I need it? Well, it depends. I'm independent consultant, so I usually start with it depends. But knowing that you know nothing or assuming that you know nothing about bucketing, I'm going to give you a straight answer. And if you know bucketing, you say, no, it's not true. And that's what I need from you. So you need it if your queries are if your joins are executed multiple times. If it's only for one-time join, there is no point doing it. It's the same technique like what you would do with cost-based optimization. With cost-based optimization and bucketing, it's the same. You need to pre-calculate some information, some metadata that you can use or Spark will use at runtime. So if it's for one or two joins, might not be very worthwhile. okay? But if it's for 10 joins, ooh, that's something I would consider and apply and just give it a shot and see if it improves my queries or not, okay? So again, the more joins, the better performance gains, okay? That's exactly why we're here. We are processing big data, we've got tons of joins, so now we can use it. Okay, so bucketing configuration. The great news is that bucketing is enabled by default, unlike cost-based optimization. So we have it, okay? We have it already available. Now we need to use it. So, well, it's also controlled by this Spark SQL sources bucketing enabled configuration property, okay? It's enabled by default, so you don't have to worry about it. Okay, so bucketing and data sources. It works nicely with data sources natively supported by Spark, text-based file formats. If you use save as table operation to save your data, or you use Hive-specific tools to, bucketize your tables, okay? So either you have it already, okay, people working with Hive did that for them, and you can leverage this information, this metadata, or you can just use Spark to, do this extra step and bucketize tables, okay? Just before you run the proper application, the proper queries. Okay, and I just included this screenshot from dataset API for Scala of Spark SQL, just to show you that this bucket by is available since here they say Spark 2.1, but in the bottom, at the bottom, you can read that it was available since Spark 2. Don't get confused. I think it's Spark 2.1. So you should be using it because the other versions are not really supported. So use Spark session table to load your tables. If they are bucketed, fine. If not, well, you can rely on bucketing. So I assume you are loading bucketed tables. So this is just a very contrived example. I'm loading I'm writing 2 tables. So I'm using large, that's any data set, and I say write bucket by for number of buckets for by ID. So bucketing column is just one column ID. I could specify more. I optionally can sort using this sort by, but be careful, it's not globally sorted. It's just sorted by, by this bucket portion of a bucket. So not much use of it. And save as table, okay? By doing this, you said, hey, Spark, do me a favor and bucketize my data, okay? Save all the information you will need later on in Metastore, and I'll be using it. So this is just the very same join, except the tables I'm using for this join, right? So again, just very simple inner join by this ID. And the point of this ID and the point of this join is that I am using the very same column in join that I used for bucketing. That's very important, because that's how Spark figured out that this is the main column it should be using for join. So if it's used for bucketing, fine. The optimization is going to be applied. Okay, so look at this. Just after doing this writing with bucket by, or by using Hive-specific tools to bucketize your tables, so pre-shuffle your data, I got this. So is it better? Well, it's better if we look at the execution plan and count the number of operations that are going to be used. And for this particular example, I see that I'll have not only less code gen stages, but also no exchanges, which is good. And I'm pretty sure that this query would beat the previous one, okay? So the time to execute it, even including the time needed to pre-bucket or bucket your tables, would be better than, you know, the previous version, especially if I run this query over and over again. So, just to give you this comparison so you can see it, on your left, my right. So on your left, you can see the query before bucketing these tables. So as you can see, there is this extra step, two exchanges, just to, you know, shuffle the data. But since we moved this shuffling earlier in our pipeline, so we pre-bucketed our data, we've got this no exchange query back, okay? And again, it will only give us performance gains if we use this optimization over and over again, this join over and over again, okay? Because only then we can amortize, we can, how to say, somehow get rid of this time we needed to bucket our tables. Any questions, by the way? Yes?
What about skewing?
Skewing. Ah, okay. So
You have skewing by, you have bucketing and skew by. Actually, to place data in a specific bucket.
okay, so the question was about skewing your data. Well, if you've got skews or skewness of your data, you need to find another way to optimize your queries. You know, if you say, okay, I want to bucketize by ID, and this ID is unevenly distributed, you will incur this skewness of your data. So your data will get skewed, okay, if I may put it this way. So what you can do, you can think if you can do partition by, so you further partition your data to lower the data you are dealing with, or you add another bucketing column. That's what you can do. Nothing else, nothing more, okay? So, yes?
It's already exists in Python, Spark SQL.
Okay, so the question was whether it's supported only for Scala, Python, R, or SQL. It doesn't really matter what front-end language you are using to express your queries, whether it's SQL or data frame, or whether there are whether you use programming languages like R, Python, or whatever. It just this is a very good question. This is a question about this bucket by that I showed you with data frame API, and this is just to show you that this is available for Scala and Java developers. In SQL, you would use distributed by. So there is another SQL. I should include it. I didn't. I should include this. In SQL, you would use distributed by to bucketize your data.
Another question. I tried before to do repartition and then write it to S3 and then read it. After I read it, it's forgot about the repartition, the amount of repartition or partition by column that I did.
Yeah.
Here, you will save it. Here, when I read the data again from S3, you will know that it's bucket by a column or something like that, or you forgot about this bucket by?
Information, so the question is, where is this information about bucketing stored? How can Spark SQL know whether your tables are bucketed or not? Is this your question? Okay, so the answer is simple. We always use, whether we want it or not, we use something that's called metastore. Spark SQL uses Spark Metastore. This is the directory you see always when you are using Spark Shell or whatever tool you are using to execute Spark. This is the Spark-warehouse. This is the local warehouse, but you can point to Hive warehouse or Hive Metastore to leverage this information. So depending on how you use Spark or how you load your data, whether it's coming from Hive tables, you already use Hive Metastore, or you are using a non-Hive deployment environment, you will be using something that Spark uses anyway, okay? So eventually, you have this information stored in a relational database managed by Spark to hold information, to manage informations like this, okay? Yes? Okay, so the question is about the relationship between bucket IDs and executor IDs. Is this correct? Okay, there is no relationship. Okay, you don't have to worry about it. I would have to go too low to explain it, but you know, in short, Spark knows what to do to make you happy. No, you don't have to configure anything because bucketing is enabled by default, except you need to use bucketized tables. Okay? Number of buckets, oh, that's a very good question. How to know how many buckets to use for our bucketed tables? Well, it's an art to know it. Okay, you need to hire an independent consultant. You need to just know your data, and this data will tell you how to bucket how to bucket itself, or how to make bins or buckets, just so you can leverage all the resources you have in your cluster. So if you know that let's say you have 10 nodes with 1 core each, okay? So I would go with, let's say, 10 buckets. Why? Because it matches the number of executors. If I'm fine with performance, I would stick with this, okay? Then I would go with 15. Why 15? 1, 5? Because I like 15 better than 10, okay? So I always tell my customers that there is no easy answers to many simple-looking questions. It's like you need to know your data, and knowing your data usually takes weeks or years, okay? Sorry to say years, perhaps I should have said months, but it takes too much time often compared to how your client can wait, okay? So eventually I say, just stick to the number of executors or number of cores, and then increase it or decrease it, okay? That's what I did with 2 clients, and they were happy. Yes?
Is there circumstances in which you need to rebucket existing columns, or it's automatically done?
Was this, okay, so if I understood this question correctly, the question was about how to pick the bucketing columns, and is it?
More so, is the bucket an ongoing mechanism, or it's something that you have to rebucket once the data changes?
Okay, very good question. Oh, this is interesting question. I'm not sure if I can answer it. So the question was, is this bucketing process ongoing, meaning that if your data grows, the buckets will grow too? Oh, let me think about it. And what do you think? What's your answer? Is this an ongoing process or not? If you are saving to Hive, Hive knows how to manage this bucketing, so it will save it properly. If you use insert into, bucketing is not supported. You will get exception. So you can only save as table, and if this table is already available in Metastore, you have to overwrite. So effectively, you remove previous information and you save new one. Oh, I've got it. Yeah, you need to rebucket every time. And with Hive, probably Hive knows how to do it, how to manage this and append information to proper buckets. But I've got no experience with Hive. Okay, let me continue with this, because I see that you've got tons of questions, which is fine, but let me finish the slides, okay? First, and this is, there are 2 or 3 slides more, so don't worry. So to know whether you are working with bucketed tables or not, you have this SQL command. It's a logical command, and by the way, logical commands in your plans are executed on the driver. So these are eagerly executed. So describe extended will give you information about your tables, or about your table. So, and extended and formatted are same, okay? So they are synonyms in Spark SQL. So use describe extended on your table, and I just picked number of rows 50 because I knew that there'll be less than 50 rows, but more than 20, and 20 is the boundary show uses for showing the results. So I just used 50. I could use 150 or whatever. But in truncate false because I wanted to see all the information rather than truncating after 60 or 80 columns. So this is the output from describe extended, okay, or describe formatted. So you can just see that I use number of buckets is 4, bucket columns is ID, and sort columns is ID too. But knowing that there is no global sorting, it's of little use, if at all, okay? So you are mostly concerned with bucketing columns. Sorting, you cannot, I could not get rid of this extra sort operation, but it's a whole stage code gen, so I didn't worry much about it. And my client was happy with, my clients were happy with the performance, so we were both fine. Okay, so number of buckets, bucketing columns, and sort columns. This is part of the answer to this question, where this information is stored. It's in Metastore, okay? So in Metastore, either in Spark managed or Hive managed. So you've got these 3 fields.
You know, it's also in Glue.
In what?
AWS Glue.
AWS, I've got no idea. No. So, summary. And bucketing, just remember that bucketing is just an optimization technique. You may use it, but you don't have to. Often, you won't even know that you are using bucketed tables and your joins are fast because of this bucketing technique or optimization. Remember, bucketing optimization is enabled by default. So if you are reading your data from externally available Hive Metastore and Hive managed data, you will get, and someone did this bucketing for some other teams, you may be leveraging it because it's enabled by default, okay? So it pre-shuffles your data, so your joins are more effective. Enabled by default, I said it, uses buckets, and as I said, knowing how to choose the proper bucket number of buckets and bucketing columns is an art, okay? So you need to just know the data and play around with different configurations, okay? Eventually, you will come up with the proper configuration and you will stick to it, okay? And yeah, so, and what's more important is that it's acceptable to bucketize just one side of a join, to get rid of just one exchange, okay? That's fine too, okay? So you can just bucketize both sides of the join or just one. And that's it about bucketing support in Spark SQL. And I finally managed to, keep the time. Thank you, guys.
Question. Yes, one question.
Is it good also for windowing? Window in Spark?
Oh, that's a very good question. I've got no idea. I would expect yes, but I'm not sure about it.
I will check
yes,
and update.
thank you.
Thank you.
Windowing, yes.
All right. Thank you, everyone. Please find Jacek offline.
Yes.